Welcome back, everybody. In this video, I'm going to walk you over in solving 8 queens problem using Ampere process. Okay, so I copied the problem to this Jamboard, and I also copied the chessboard as well, and also the icons of empty square and a square with the queen sitting. Okay. So just to illustrate to you guys, but in an interview setting, I recommend just create a 8 by 8 grid and then try to do your understand process. Okay, so let's first try to identify the inputs. So I'm going to quickly get a textbook and inputs. All right, so this change this to all right. So there are two inputs. One is X, okay, and the other is Y. So this X and Y coordinates come in as two separate slits. And you can see it over here. If you take a good look at um, the code check, you can see there are two separate lists, okay? And then those data is given to you, okay? All right, so let's go back. Okay, so let's try to let's read the problem again. Okay, so if it is possible to place 8 queens on an 8 by 8 chessboard so that no two queens threaten each other. Thus, it requires that no two queens share the same row, column, or diagonal. Okay, so then basically, given a placement of 8 queens on the chessboard, if there's a pair of queens that violate this rule, print yes, otherwise print no. The input consists of 8 coordinate pairs, one pair per line, with each pair giving the position of a queen on a standard chessboard with rows and columns numbered from 1 to 8. Okay, so this is the chessboard. Now, notice the rows. Okay, so rows the columns are actually x coordinate, okay, and the rows are y coordinate, okay. So if you quickly draw x-axis right here, let me just right. So this is x, okay, and then this is y, okay. So so that's y, and then this is x. All right. So, so let's try to figure out these things. Before that, um, let's yeah. So the criteria is right. So if two queens share the same row or same column, then it's a violation of this rule. Basically, we have to print yes. Okay. So so let's in this form. This is actually the first data set. So I'm going to actually create that data set right now. So let's quickly, all right? So x equals, and we start off with um, x is 1, right? So right here, x is 1, and then the next one, x is 2. So all the way go up to 4. Okay, all right. So in this form, now we can see that no two queen is sharing the same row or same column or same diagonal. Okay. All right. So, but let's create the scenario in which they are sharing. Okay. So what I'm going to do is I'm going to move queen, this queen into um, right here. Okay. All right. So now these two queens are sharing, right? So if we take, so now this queen is 7, right? So change the uh, coordinate to 7. y is 7. So now see that two y coordinates are now same, 7 and 7. So that means they are sharing a row. Okay. So uh, similarly, we can try to do right here as well. Okay. So now they are sharing a column. Okay. So now it's this is it should be 4. This become 4 and this becomes 6. All right. All right. I think, yeah, I think that is it. Yes. Yeah. Okay. So now we can see that two columns are now common. Okay. So we have two queens in the same column. Okay. So, and then the other scenario is what will happen if this queen, let's say, like if I move this queen right here. Okay. So now notice they are in a diagonal. Okay. So it could be right here or right in this diagonal or in this diagonal. Okay. So I'm going to move it right here, move the queen right here. So, so now, so let's change that. It should be 6 and 5. Okay. So this was this over here. So this become 6 and 5. Okay. All right. So, so what happened over here is that basically now we should be able to see this square, right? So basically, when two things in a diagonal, they form the corners of a square. Okay. So that means if you take the difference between the 2x coordinate and the 2y coordinate, they should be equal. Okay. Because it forms a square, right? So since this is a length now, and we should consider getting the absolute value because it should be something positive. Okay, regardless the position right here or let's say right here. Okay, so if this queen is right here, right? So if we take the difference side length of this square, and then we could get negative values, but since it's a square, we should get the absolute value. Okay, and compare that. Okay, so length and the width of the square, basically they should be equal. So the length comes from the difference between x coordinate, width comes from the difference between the y coordinates, and they should be equal. Okay, all right. So let's now write our um, algorithm on this one. Okay. All right. So first we take input, and that's x and y. Okay. They are lists. Okay. 2. Okay. So we should get this value. We just initialize this value. So init the things return value, right? So let's say we can take like yes, no, both, and you can initialize that to no. Okay. 3. All right. So we need to check this from starting from the pair 1 and then move on to the next likewise, right? So basically we need to start right here and then check against this likewise all the way up to n. Okay. So when we do that, basically we're going to cover entire chessboard. Okay. So and then basically if we take this pair and we need to check this pair against all the others, so that's going to be the inner for loop. Okay, and then we go to the next pair and then we're going to check from there on the next set of pairs. Okay, so that means we need two for loops over here. Okay, So, all right, I'll take the first x coordinate at xi. Okay, so it's I. Okay, in basically, let's say from 1 to 8. Okay. Okay. And then the inner for loops. So basically, we need to now check this pair against the rest, right? So that's the inner for loop. Okay. So in the outer for loop, we're going to consider each pair of x and y values. And then inner for loop, we need to check that pair against the rest. So here, the for loop start, let's say j from I plus 1. Okay. So for example, if it is this one, the first pair that pair of x and y we're going to use, and then this should be I plus 1, right? So from I plus 1 to 8. Okay. And then the condition should be, okay, 3.1.1. The first condition is basically you're going to check whether it's single row or single column. Okay. So if it is a single row, okay, all right, so the x values are same, right? So if xi, okay, equals xj, okay, all right. So if that is the case, right, and then it's basically the violation of criteria. Basically, they cannot sit in the same row, right? So that means um, we have to say yes. So we have two more conditions. So it's O. So either of these valid. So next one is actually Y, right? So Y I, okay, equals Yj. Sorry, Yj. So then basically we need to there's one more, right? So how do we check the distance, right? Like how do we check for the diagonal, right? So this diagonal may come from either side of the queen, right? It's the queen in consideration. So basically we have to check for absolute values now. Okay. So it's the absolute value going to be, right, xi minus xj. Okay. So x, right? So we're gonna take these xi, right? Xi minus xj. So that's xj. Okay. So that is basically this distance. Okay, right here. So right. So let me move this queen right here. So just take this as an example. So xi minus xj is that basically this distance. Okay. So right, xi minus xj, and this distance yi minus yj. Okay, and then they have to be equal. So notice that one of this would be positive, the other would be negative. So only the magnitude should be equal. Okay, so we take a absolute value. Okay, so we can write, okay, absolute value of that, and that equals Same thing for y. So absolute value of y I minus yj. Okay. All right. So that's it. So if this is the case, we can simply return yes. Okay. Else, or basically, yeah, we can update this value and then return the value. That's fine as well. Okay. But I'm gonna leave it like this, and basically, if none of these doesn't work, basically that means this criteria didn't meet, then we can basically return no. Okay, so this is the plan. So let's go back and then this let's solve this problem. Okay, so I'm going to take this and copy this into my PyCharm, and okay, so let's give it a name. Check queens. Okay, and it would take two parameters, the two list x comma y. Okay, all right, and don't forget to write the docstring. Okay, so in here returns yes if two queens share row or column or diagonal. Otherwise, returns no. Okay. So please consider doing it. Don't forget to do that because interviewer most probably looking forward to it, because simply many companies want their engineers to document their work. Okay, so that's simply it is. All right, so we already got our input. Okay, so again, in here we don't need second step because I simply returned values. So we can start for loop for I in range 8. Okay, so and then the next for loop. Okay, so for j in range I plus 1 to 8. Okay, all right, and then I can simply I miss if they are, so if I can simply copy paste this. All right, all right. Okay, so let's okay, all right, so yeah, okay, so and then we return yes. Otherwise, at the end of the to for loop, we can return no. Okay, so we don't need to have else there, just return no. Okay, all right, so let's check this out for the first coordinate set. So I'm going to copy that also from the Jamboard. Okay, so for these two. Okay, so we need to print the call to see the value. Okay, so let me run this. All right, so it's a no, right? So we don't have for this test case. Okay, so first one is no. Okay, so let's take the one with yes. Okay, so this one 8 7. So the opposite. So basically, all the elements are in diagonals, or not all the queens are in diagonals. It seems like, okay. So 1, 8, and 7. So basically, it's easy for us to change this. So I'm going to copy this whole thing and run it again. Okay. So this would be the opposite direction. 8, 7, 6, 5, 4, 3, 2, 1. Okay. Let's check that. So I got yes. So here you go, the implementation of 8 queens problem. Okay. So I said to you guys, okay, how can we actually use this function in a different program, right? So I'm going to take quickly write a new program. Okay. New Python file. So let's say check import, because we're going to import this code. Okay. All right. So basically import, right? And then this 8 queens too, right? So I can simply do that. Okay. So, but there's a problem, and I'm gonna show you how to solve this problem. So in this program, I'm just simply printing hi, but hi, and then also I need to uh, call this function again. Okay. So let's say I have a same data set. Well, I can change something. Okay. All right. I'm going to change this to 4. Well, it's still going to be yes, right? So, and then use that function, right? So, okay. So this is how we use it, dot. Okay. And it's going to show you. Okay. And can print now. Okay. So that's a problem though. Okay. So notice that I'm only running this for these 2 values, and look what happened. Okay. So I'm going to run this program now. So I am going to use the code that I previously wrote. So this is an example of code reuse in Python. Okay. All right. So run it. Okay. So all right. So let's see. Oh, I didn't put the argument. So let's see x and y, comma y, and we run it again. All right. So notice it. I only ran once the function, but it ran the entire imported program as well. Okay, so this is the problem, because I only want to call this function. I didn't want to run this program, the entire program, but simply importing like this and calling the function ran the entire that program, right? So how do we solve this problem? So here's how. Okay, so in here we need to actually write our main program. Okay, so I'm going to quickly write it over here. Okay, so def main, so that's our main function, and I'm going to basically put all of these in there. Okay, all right, so that's in there. So then we need to call this main. Okay, so we're going to call this main in this form. Okay, so if name, okay, that's an internal variable called name, okay, equals main. Okay, then only run main. Okay, all right, if this is the case, only run main. Okay, now when I run this program, so I'm going to run 8 queens now. Okay, it's gonna work this way, right? So it runs fine. Okay, So then I import this and call this program. Let's try now and then see what happens. Okay. So I'm gonna call it. I'm gonna run this program. Okay. Well, it didn't run, right? It didn't run the 8 queens. We only imported, we only call the function that we want to run inside. Okay. So here's the reason. Okay. And I can simply put this as well, this whole thing in a main as well. So let me do that as well. If main, okay. And it's the same thing. All right. And I'm going to call main like this. Okay. Let's run it again. Still the same thing, right? So here's why. So this construct check this name variable. So when we run Python instance, it only takes the current running program as the value. So in this case, when I run this program, this is the main. Okay. So this program is the main program. So it runs only this one. Okay. So then the problem is gone because I am only going to run this current main program that we are running, not this one. Okay. So simply we could only import what we wrote. Okay. So I highly encourage for you guys to follow this technique, especially if you have multiple packages, imports, and then working in a group or team and collaborating in a big project. Usually, there's only one client program, which is the user. So you write this program and this way, and then you can import the contribution from others like this way. Okay, so you can practice every time you do this. Well, when you submit your solution, you don't have to do that. You simply copy paste this into the solution, right? So let's do that as well. Okay, so I'm gonna go here. Okay, and this one. Okay, so don't forget to adjust the indentation. Okay, and this should work. Let's check our code. Yep, we pass all the tests. Okay, all right, there you have it, guys. Solution to 8 queens problem following Ampere process. Okay, so one thing in here, code check, we didn't do that way of configuring your solutions because code check has its limitations. But when you solve your problem in your own environment, please try to follow that way of writing your solution.